So now we are going to move to the next phase, which is exploratory data analysis. Before I go there, I wish to go to the mind map and then explain you a few things. Here, phase 2 of CRISP MLQ happens to be data cleansing, which is also called as data preparation, which is also called as data munging, which is also called as data wrangling, which is also called as data organizing. And there is also another name which is called as data pre-processing. These are the various names which are provided for this phase 2 of CRISP MLQ. While for theoretical discussion, I've segregated point A, B, and C as 3 sub-phases within this phase 2. While we could do that, practically, you cannot segregate these. From a practical standpoint, you will not be in a position to segregate these 3 sub-phases. Okay, so you have 2A, which has bunch of stuff which we have to talk about, and you have 2B, wherein you have a bunch of things which we need to talk about, and then you have 2C. However, I wish to get started with 2B, which is exploratory data analysis or descriptive statistics. Because once we understand these measures, etc., it will make our life easy in terms of understanding the various data cleansing stages. So there is a dependency in terms of understanding these. First moment, second moment, third moment, fourth moment, and graphical representation to be able to understand 2A. Hence, we would first delve into exploratory data analysis. In order to understand exploratory data analysis or descriptive statistics, one needs to have knowledge about probability, probability distribution, inferential statistics, etc. So we would first look at these basic statistics, and then we will get into exploratory data analysis. And once we are done with all of these, we would then also look at Python programming. We would try to accomplish each and everything in Python. Once we are done with that, we will get into data cleansing or preparation steps. Okay. So let me proceed further with this. Here is our agenda. We will try to understand what is a random variable, what do we mean by probability. The moment people hear about probability, they are like, oh my God, probability is back again to haunt me. In the school days, I thought probability would be something that will never haunt me. Okay, so don't you worry, friends. We will try to take it in small stages. Okay, even if you have hatred towards this term called probability, don't you worry, we'll try to make it as simple as possible. Okay, so we will talk about random variable probability and probability distribution. Then we will get into inferential statistics. Then we will get into measures of central tendency, then measures of dispersion, then expected value. With that, we'll conclude this specific module, and then we'll get into a different module. Okay. So say you have a die, and when you roll a die, obviously, you might get 1 or 2 or 3 or 4 or 5 or a 6. Die is singular, dice is plural. I'm sure you guys are aware of that. Anyways, suppose you roll a die. Of course, die is singular anyways. And then what is the probability that the outcome will be bigger than 3? Suppose this is the question that we want to solve. First of all, we need to understand the formula for probability. And friends, we are now in phase 2 of CRISP MLQ, which is data preparation. Okay, that's why the heading is data preparation. The formula for probability is number of interested events divided by total number of events. Number of interested events by total number of events. If the question is, if you roll a single die, what is the probability that the outcome would be bigger than 3? That is greater than 3. What are the different values which are greater than 3? You have 4, you have 5, and you have 6. You have 3 values. So the number of interested events will be 3 divided by total number of events. In total, how many events do we have here? 1, 2, 3, 4, 5, and 6. And this would be 1 by 2 or 0.5. If you have, if you roll a die, and what is the probability that you would get a value which is equal to or bigger than 3? Equal to or bigger than 3. Okay. So equal to 3 is 3 also, and bigger than 3 would be 4, 5, and 6. So going by this formula, the number of interested events happen to be 3, 4, 5, and 6. There are 4 events divided by total number of events happen to be 6. So you get 2 by 3. Then, what is the probability that if you roll a die, you get a value which is smaller than 4? Smaller than 4 would be these values. 1, 2, and 3 are values, numbers which are lesser than 4, smaller than 4. So you have 3 events. Number of interested events would be 3. Divided by total number of events, which happen to be 6, which is 1 by 2. Okay, then if you roll a die, what is the probability that you get a number which is greater than 2 and lesser than 6? So greater than 2 and less than 6 would mean the values in between 2 and 6. In between 2 and 6, you have these 3 numbers. So for this, if you were to calculate the probability, it would be number of interested events, which is these 3, divided by the total number of events, which is 6. So you get 1 by 2. This is how simple probability discussion is. At this point of time, until we get into a few concepts, the only formula that you all should be aware of is probability is equal to number of interested events divided by total number of events. This is all that you need to be concerned about until we complete a few concepts within data science. Okay. Now, a lot of people keep asking me this question on, hey, Bharani, can you give us access to a few books? Because we believe when we read books, we will understand even better. In my lifetime, I would have read 150 plus books, easily related to data science, related to statistics. And I would have worked on 150 plus projects, either directly or as part of my consulting engagements where I guide the team of data scientists. All that experience is brought into the training curriculum here. Okay. Given that, any statistics book that you pick up would contain a reference of something called as random variable, which is considered to be the basic when it comes to statistics. All I would say is read this statement. And if you can understand this, then reach out to me and ask me for books. I am going to help you guys. I have a bunch of books, all licensed, all purchased, not downloaded from torrents. Okay, everything has a license, and I'm going to give everything to you guys for free. Of course, I cannot reproduce, but I can probably share with you the license copies. But all you need to do is read this and explain me, okay? What does it say? A random variable describes the probabilities for an uncertain future numerical outcome of a random process. For people who read it for the first time on statistics books, you'll be like, immediately you'll close the book and say, hey, this is not my cup of tea. Happens. Okay, so we will try to understand this in the simplest of the manner possible. First, we are going to divide this into two parts. We are going to divide this as variable and random. What is a variable? Variable is something that is going to vary. For example, if I flip a coin, you might get a head or you might get a tail. So flipping a coin might give you a head or a tail. If I roll a die, I might get 1 or 2 or 3 or a 4 or a 5 or a 6. If I flip a coin, will I always get a head? No. I might get a head or I might get a tail. That means output varies. If the output varies, it is called as variable. If I roll a die, would I always get a 1? No. You might get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So the output varies. If the output varies, it is called as variable. Point number 1. So variable part is clear. What about this random? Random means if you have a chance associated with each of these possible values. Chance means probability. And we already spoke about probability and we understood that formula is number of interested events divided by total number of events. So what is the probability of getting a head? Head is a single event. So you are interested in head, which is a single event divided by total number of events are 2. What about probability of tail? Tail happens to be a single event. So number of interested events would be 1 divided by total number of events, which happens to be 2. And another property that you need to remember is that when you add the probabilities of all the possible values, which in this case happens to be 1 by 2 plus 1 by 2, would be equivalent to 1. So when you add the probabilities of all the events, it will be equivalent to 1. So the overall probability is 1. And this 1 is getting distributed to head and tail, to these two possible values. If you roll a die, what is the probability that you would get a 1? 1 is a single event. Your interested event happens to be 1, which is a single event. So you'll put 1 divided by total number of events. Here, total number of events are 6, so it's 1 by 6. What is the probability of getting a 2? The interested event is 2, which is a single event. So you put 1 upon total number of events, which are 6. So you get 1 by 6. Then what is the probability of getting a 3? 3 happens to be a single event. Divided by total number of events are 6. For 4 also, it will be 1 by 6. For 5 also, it is 1 by 6. And probability of getting a 6 is also 1 by 6. And what is the property? If you add all these probabilities of all the values, so probability of 1 plus probability of 2 plus probability of 3 plus probability of getting a 4 plus probability of getting 5 plus probability of 6. So each of these is 1 by 6. 1 by 6 plus 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 1 by 6. When you add all of these, you get 1. So probabilities of all the values, all the possible values of an experiment, when you add them, you get 1. So the overall probability is 1, and this gets distributed to all these events. Probability of 1, 2, 3, 4. You're distributing 1 across all these events or all these possible values. And when you distribute a probability across all these values, it is called as probability distribution, because you're distributing this probability to all the possible values. So that's random. Random means every possible value will have a probability. Variable means the output varies. If you have both these properties, it is called as a random variable. For example, if you look at age or income, whatever, it would be represented using a random variable, but you use an uppercase. Okay, if you have age, you use an uppercase. It can be an uppercase A or B or C or D, whatever, right? Uppercase mark. Say the age of first person happens to be 32, second person is 28, third person is 18, fourth person is 46, etc. Each and every value of this random variable would be denoted using lowercase. So x1 is age of the first person, x2 is age of the second person, x3 is age of third person, x4 is age of fourth person. Whenever you look at any of the statistics books or data science books, if you have an uppercase notation, that means we are talking about a random variable. Okay. And if you have lowercase values, lowercase notations, that means you're referring to each and every value within that random variable. Okay. And if I were to ask you, a lot of you all must be working on what do you think is the mood of your manager? Will the mood of your manager, or for married people, do you think the mood of your wife will always be the same, or would it vary? Would that be a random variable? I'm sure a lot of you all will say yes, right? So mood of your manager might be like that, varying. So that's nothing but a random variable, because it always does not remain the same. All right. So this marks end of random variable concept. And we will move to the next concept in a moment.